Okay. All right. We're starting with chapter 17 or 13 in wholes. Okay. So give me a second. Let me pull up that PowerPoint just to give you an idea. Big enough? All right. So.
I know Kat works, so she probably would have came if she could have, but she has
Okay.
work, and she gets out till 3. So.
Yeah. All right. Now, hormones. You need to understand that they're either going to be steroid, lipid-based, or non-steroid, protein-based. All right? And the cool thing about this is the name of the hormone will have stir in it. Got it? So if we look at our list of hormones, remember that hormone, the big old list of hormones? Right there, yeah. If you look at that big list of hormones, you'll see aldosterone, estrogen, got it? Testosterone. Anything with stir in the name, beginning, middle, or end, means it's a lipid. The other ending we need to know is OL. Okay? That would be cortisol. Got it? See the word stir. Okay? Stir. Cortisol. Stir. Got it? All right. Now, what is so special about you being a lipid-based hormone? Well, what do we have here? Membrane, right? And these are the bilipid layer. Got it? Where the lipid tails are facing each other. They have no charge. Got it? Well, guess what? These steroids have no charge, so they go right through. Straight in through the membrane, straight through the nuclear membrane, straight to the nucleus.
They're nonpolar.
They're nonpolar. Got it? And nonpolar goes right past nonpolar. 10-4? And that's why they have to have an internal receptor. A receptor that is in the nucleus that has to attach, okay? And that's how you know it's the correct target. The target is the correct target for the hormone because the target has the correct receptor. Got it? And all receptors are made of protein. Why? As we learned in 210, proteins come in billions of shapes, and it's all about the shape. You know? Round peg in a round hole. I can't put a square peg in a round hole. Got it? Okay. So the lipids have to have an internal receptor because they can go right through the membrane. Got it? How about our proteins? The guys who end in INE or just end in IN, like insulin, they cannot go through this membrane, so they have to land on an external receptor. Got it? A protein on the outside with the correct shape. And because they can't enter, how are we going to get that message to the nucleus? We use the second messenger system. Got it? On the inside of the membrane is another protein called a G protein that then is launched and has several steps to make the second messenger, usually called cyclic AMP, CAMP. And that cyclic AMP is the one that goes to the nucleus. It becomes the second messenger. Got it? The first one is the protein, but it can't come all the way in, so we have to create a second one. Got it? And that's going to be a test question. You know, if I give you a list of hormones, who needs a G protein second messenger system? Pick the one that's the protein. Got it? Series of hormones. So if I say, who is a primary messenger, that'd be any of these, because they go straight in. I don't need a second messenger for these guys. They are the message. Does that make sense? So on your test, you just have to be able to tell me who uses an external receptor, who uses an internal, who can go all the way in, who can't go in, and, can you tell them apart? Is one a steroid, is one a non-steroid? Now, here's another cool thing. As I said to you guys last night, right? You want to learn the easy way or the hard way?
Easy way.
The easy way. So, all you got to do is realize these are the only lipids. Everybody else is a protein. Even the ones that don't have IN in the ending because they're named growth hormone. Got it? Now, oxytocin, IN. Got it? But ADH doesn't have an IN, but it's a protein. Got it? Everybody's a protein except for these 6 that are lipids. 10-4? All right. How's that? Does that help?
Yep.
Okay. So that's how you want to make sure you understand what's going on for that configuration. Is there anything else you need? Because I'm not going to get all bent into shape and say which one's an amine, which one is a peptide, meaning a small protein. No, I would never do that. You're either a lipid or you're a protein. Okay? Is there something else? Because I'll just scroll.
No, I'm good on that part.
Okay.
Yeah.
How about the hard one? The permissives and the... You want to do that one?
The permissive, that's the one that gives permission.
Yeah.
What you said about it. It needs a second one in order to work better. The
Yeah.
one that second works better than the first one. Which
No, it
allows
doesn't
to
work better. It's just that you have to have the first one there present for the second one to do its work better.
Oh,
Got
I
it?
think
yeah.
what you had said in the video about how when bodybuilders will take growth hormone
Yeah.
with testosterone
Yes.
and that makes it work better.
Yes.
But
That's the answer. Yeah.
okay.
Yeah. So,
It'll that one will still work with or without it. It just works better with
yeah,
it.
it works
Okay.
better. Yeah. That's the whole point.
Okay.
That's what a permissive is. It's sort of like, I think I might have mentioned in the video, if you want to take mom's car, you need mom's permission. Mom's not going to chaperone you. She's going to give you the key, but if you don't have the key, you're not going to get anywhere. See? Mom's not doing the driving, but mom's giving you the permission. So, testosterone isn't growing your muscles. Growth hormone is. But testosterone makes the growth hormone work better. That's why women bodybuilders use testosterone. Got it? Because estrogen only builds you female body types. Does that make sense? So estrogen plus something else is a permissive situation. Testosterone plus something else is permissive. Who's the third permissive? It'll jack up your metabolism so the second one works better. Thyroxine. Got it? So thyroxine and something else is another permissive. Okay? In other words, I need thyroxine to make EPO work better. I need thyroxine to make something else work better. Got it? But when you really want to make hormones work, you give them testosterone. Testosterone plus anything makes it work 10 times faster. And that's the roid rage that they're talking about. You're not raging because of growth hormone. You're raging because of the extra testosterone that you're taking.
So when the test is gonna be like, what's an example of a permissive?
Right.
Or like which?
And then you pick from a list of 2 hormones at a time. Got it? It's always going to be 2. Got it? Because it takes 2 to be synergist. It takes 2 to be antagonist. It takes 2 to be a permissive, and the one being permitted. Got it? So it's going to be a series of 2. So all I would say, again, the easy way is remember estrogen plus something, testosterone plus something, thyroxine plus something are all permissive. Okay? Now, what is a good way to remember the antagonists?
How they work against each other?
Exactly. They're the opposite. Got it? So, which one makes you hold salt.
Water.
No, which hormone? Water ain't a hormone.
Okay.
Which hormone says hold salt?
Uh,
Keep the salt in your blood. Don't pee it out.
it's that big word, the the ADP or aldosterone. Okay.
Big Al. That's aldosterone. Okay? Now, which hormone says pee out your salt?
I'm going to say it wrong. Atrial natriuretic peptide, or ANP.
Yeah, ANP, which stands for atrial, because who makes it?
The heart.
The heart. What's natrium?
Salt.
Salt. Natri. What's uresis? Pee out. And it's made of a peptide, which is a type of protein. Got it? ANP. And see how that's exactly the opposite? One says hold your salt, one says pee out. Am I on there?
No, you're good.
All right. Now, who is the synergist? Works hand in hand with, ends up making the same thing. Who's the synergist to Big Al? When you hold salt, what are you telling your kidneys to do? Oh, please don't forget this. This will save you guys in nursing school. Ready? Water, what?
Follow salt.
Follow salt. So, if aldosterone tells your kidneys, put the salt back into your blood, what else am I holding?
Water.
Water. So, who's the other hormone that makes you hold water? Who makes you hold water? Anti-diuretic hormone against peeing. Diuresis means to pee. Got it? Excuse me.
Let's see.
Therefore, these two are synergists because they both end up telling your kidneys to pee less. Got it? But these two are antagonists because they're the opposite to each other.
Is that an atrial or
Atrial, yeah, I-A-L, atrial. Yeah, sorry,
No, I got it.
I write too fast. Atrial, meaning comes from the atrium. Okay. How's that? Is that good? Okay. So, what is a good way to remember your antagonists? It's very simple. They work to keep this in homeostasis. So, here's two antagonists for salt. Got it? Salt in, salt out. What are the two antagonists for glucose, high and glucose low?
Insulin and glucagon.
Insulin and glucagon. They're antagonists. Who are the antagonists for calcium level high, calcium level low?
No.
Don't make it hard.
Cortisol?
Oh, calcitonin.
Calcitonin
And
lowers your calcium by putting it into your bones.
the parathyroid.
Yeah, and PTH raises your blood calcium by digging the calcium out of your bones. But they're opposite. One puts it in your bones, one takes it out of your bones, right? Because it's all about keeping you in balance. It's all about keeping you in homeostasis. So I keep my salt in homeostasis, I keep my water in homeostasis, I keep my sugar in homeostasis, I keep my salt in homeostasis, my calcium. Does that make sense? That's why a lot of your hormones are antagonists. Now, does every hormone have an antagonist? No, there's no antagonist to growth hormone. There's nothing that makes you shrink. Got it? You just grow, and then you stop growing. 10-4? Okay. Prolactin, you make milk or you stop making milk. Does that make sense? Okay. Okay? What's another concept that might be difficult? I'll go pull this back up. You look at your study guide and see there's something that your fellow observers might need a little help with.
Is the next class going to be harder than this one?
Yep. Yeah, 'cause this isn't hard. Come on.
What next class are you referring to?
Like the class after this one, 210 to 11, and then the class after. I don't know what's.
Oh, you mean the next class like micro?
Yeah, like micro.
No, that's easier.
Really? Okay.
Well, think about it. Are there as many different parts in a bacteria as there are in a human being? No. So the hardest thing in micro is learning all the steps of transcription and translation in detail. Okay? Yeah. So you got your starter amino acids and your ending amino acid, that kind of stuff. Your lac operons and stuff like that. So yeah, it's a lot more detailed when it comes to the genetics of it. But no, there's only so many diseases, only so many things that these critters do and whatnot. And the next thing is your lab, which is where you get to do, let's grow this, let's grow this. How do you test for this? How do you test for that? And then at the end, you have your unknown, where they give you a vial of something, and you got to do all 8 tests to see which one of the bacteria you have. If you're lucky, it's the first test. It tells you, boop, it turned green, that's what it is. Got it? You still have to do the rest of the test to prove that it's not the other stuff. Got it? The students who start sweating are the ones who, they don't show up till the 8th test. Negative, negative, negative. Oh my God, I did something wrong. Yeah, okay, the last test, yeah, you're positive for that. So it's not hard. Okay? All right. So remember, we said lipids, straight in. And remember, you can always tell it's a lipid because it's got this configuration of 6-sided, things put together. That's what your steroids look like. That's what your cholesterol looks like. Okay? So a few things sticking out of it that makes it a steroid hormone. All right? But basically a steroid, basically a lipid. Right through the membrane, right into the nucleus. But how do I know I'm at the right nucleus? I have an internal receptor that fit. Got it? Lock and key. And now I can talk to the DNA and say, hey, make this protein. Hey, do this, do that. Okay? That's your lipid. All right? So your protein, on the other hand, the non-steroid, the protein, has to land on a receptor, and it better be the right shape. Got it? And once it's in there, the G protein down here gets launched and creates, using ATP, the second messenger called cyclic AMP. Got it? So its receptors to the surface, we call that an external receptor. Okay? And then, now that these proteins have been activated, it can either go to the nucleus and tell it to go do something, or it can actually open a gate on the membrane. Okay? But I can't do it unless I have a second messenger system.
So we can kind of get fat easily, but we can't let protein.
Well, I guess you could say that. Yeah. It's definitely easier to add
fat.
Okay? Does that make sense? Okay. All right. Was there anything else on your study guide that was a little confusing?
My Wi-Fi isn't working, so I can't really look at it.
Is it working not in here?
On my computer, I might just have to use my phone.
Compare ACTH and thyroxine receptors. Thyroxine was. Oh no.
What do you need?
Will you go over ACTH and thyroxine? When it says compare those receptors, is that just talking about how?
No, I know exactly what you're talking about. Okay, I'll just say it because it's just one line on a PowerPoint. Okay, where does ACTH come from? What's the origin of ACTH?
The anterior.
The anterior pituitary. Got it? Because AC stands for adrenal cortex. What's the T? Thyrotropin. Now, not thyroid, but tropic. Okay? The word tropic is the same as tropic. Okay? You tell me, where do we have more stimulus of life? In a desert or in the tropics?
In the tropics.
So the word tropic, like tropical, means stimulated life. Okay? So tropic means the same thing as to stimulate. That's why you can have thyrotropin is the same thing as thyroid stimulating hormone. Okay? So the adrenal cortex doesn't have the word stimulating, it has the word tropic in it. Adrenal corticotropic hormone. So what are we going to do? Go to who to stimulate? The adrenal cortex. So that's the outside of the adrenal gland. Remember the adrenal gland is a little hat sitting on top of the kidney. Alrighty? So, where are the receptors for ACTH? Only on the adrenal cortex. Because the name tells you, I'm only going where? The adrenal cortex. Now, your thyroid hormone, which jacks up your entire body, where are its receptors?
Inside the medulla, the cortex as well.
Every cell of your body. Because if I want to jack up your metabolism, do I just jack up one arm? Do I just jack up one leg? No. If I jack up your metabolism, it's your whole body. So every one of your body cells has receptors for thyrotropin. Got it? Oh, for thyroxine, not thyroid,
Okay.
thyroxine. It comes from the thyroid, sorry.
And
Thyroxine. Got it?
try,
Think about
T3. Would
And
that be
T4,
the-
I'll tell you that.
would
Give
be the
me,
same
give
thing?
me one more. I'm going to add one more thing.
Okay.
Insulin. Where are my insulin receptors?
In your kidneys?
Nope.
No, your liver?
Nope. Insulin talks to your entire body. It tells all your body cells, open a door and take in the glucose. Got it? Not just one arm, not just one leg, not just one kidney, not everybody. Because everybody needs glucose to do cellular respiration. Got it? So the receptor where the insulin lands has to be everywhere. Got it? But not a hormone that specifically goes only one place. See? All the hormones that come out of the pituitary go to one place. Got it? The follicle stimulating hormone goes to the eggs, the follicles. We're not stimulating follicles in your eyes or in your hair or in your fingernails. Only your eggs or my testes. Does that make sense? So that's very specific. A specific target. Got it? But the hormones that the rest of your body makes go to many body parts. Got it? Does that make sense?
So what's the one that goes to the the main thing, like
I don't know what that
ovaries,
means. What's the main
or
thing?
what do you mean, like the ovaries, like straight to the ovaries or straight to the test, like you said?
Yeah, any of the
What is that?
gonadotropins do that.
Gonadotropins do.
Yeah,
Okay.
because we're gonna tropin stimulate your gonads. So
Okay.
your gonadotropins are things like FSH and LH, and then later on you're going to find out estrogen and progesterone. Okay, because they have an influence. Testosterone has an influence on only one thing. You got it? When you are talking about growing. Now, estrogen and progesterone do have secondary characteristics displayed in the rest of your body, ladies. And testosterone has a secondary characteristic in males, the beard and I'm big and bad. Got it? So they do have receptors in other places. Okay? But the gonadotropins in particular only go to the gonads. Thyrotropin only to the thyroid. Got it?
I haven't finished watching.
Adrenal cortex, adrenal corticotropic, only the adrenal cortex. See, the name tells you that's where I'm going. Got it? It's not 50 places, one place. Okay? Where's prolactin going? To the mammary glands. Because you're not going to make milk in your toe. You're going to make it only in your breasts. Ladies, not guys. 10-4? All right. Go ahead. You had a question?
I was gonna say another thing that would be good to touch on would be the difference between free and encumbered hormones.
Yes.
That would be free, meaning that it just travels through the blood freely.
Yep.
Encumbered meaning it has to attach to a carrier protein.
Yes.
Okay.
Who needs a carrier protein?
The
Do oil and water mix? So lipids need to be attached to a protein. Because proteins are polar, just like the water of your blood is polar. Got it? So non-polars won't flow in your blood. They'll stick to the walls. Is that what you want? You want your hormones to stick and create plaque buildup and not get to where they need to go? No. So steroids have to be encumbered. Now, where does that word encumbered come from? Think about going to your prom. What does a guy wear? Cummerbund. Does they go around him? That's what these proteins do. They go around. Okay?
Are there any protein encumbered?
Yes.
ones?
There's one protein that needs to be encumbered. Thyroxine. Why? Because thyroxine is made from a lipid called colloid. So it still has a lot of lipid qualities, so it needs to be attached to a protein. So it's the only protein that needs to be attached to a protein. It's the exception to the rule. Got it?
So the protein that needs to be encumbered is the what?
Say again?
What protein needs to be encumbered again? The thyroid.
Only one, thyroid hormone.
Thyroid.
T3, T4. And what's the difference between T3 and T4?
It's
Three.
functional.
No.
Three is
T3 is made of 3 iodines,
Oh,
and T4 is made of 4. That's why it's called tetraiodothyronine or triiodothyronine. Make sense? And they both jack up your metabolism. One is slightly different than the other, but that's not on your test, so I wouldn't worry about it. Just realize that whether it's T3 or T4, you're jacking up your metabolism. And not just in one part of your body, but your whole body.
I was gonna say, would you cover the all of the so this question specifically, discern the results of high and low production of thyroxine, cortisol, and then you have blank there.
Yeah.
So just the
diseases.
The diseases.
Sure,
Yeah.
sure. We got them on here.
Is the other one calcitonin?
Well, calcitonin doesn't do with thyroid. But there are problems with too much and too little calcitonin, yes. All right. For example, see, 200 gigantism, or acromegaly, where you stop getting taller, but your bones are still growing. See how his brow got bigger and his chin got bigger? That was him at 18. His face was fairly normal. But at 18, he's pretty tall, don't you think? Okay. That's all I'm ready to John.
And this also talks about the question before that, which is saying the result of growth hormone before and after.
Yeah, that's it. Before and after the plates.
Okay. Yeah.
While the epiphyseal plate, the growth plate, is open, you just get taller. Mm-hmm. When that plate stops, you don't get any taller, but your bones are still growing, and so the edges of your bones stick out. And that's what this means. Acromegaly. The edges get big. The edges get big.
So acromegaly is when your face starts to look
Yes,
weird,
your
but
face starts
gigantism is
looking
just
weird.
your bones look.
You're not
You
getting
get
tall.
taller,
You're
but your
already
bones-
as tall as you're going to get.
Yeah.
Because now your epiphyseal plates have closed.
But your
Here, let me
face
show you
still
another
looks-
picture. There's
Okay.
another picture coming up. See? You might recognize Richard Keel from the James Bond movies. He had acromegaly. See his chin? See his brow? This guy, he used to be a wrestler, and then he became a bad guy in the old black and white 1950s movies. That's the great Khali, who was a wrestler. Check out his chin. See, acromegaly. He's as tall as he's going to get, but his bones are still growing, and that's why, look what happens to your jaw. Because your jaw is still growing. Got it? Okay. Did that help? All right. Alrighty. And if you don't have enough growth hormone, because your pituitary is working less normally, hypo, look, the whole body is small. Okay? As opposed to this, that's achondroplasia. The head and the torso are the same size as ours. Their long bones are shorter. Because what do all long bones start as? Cartilage. And that's why this is called achondroplasia. Growth of your cartilage, not. A in front of any word means not. Does that make sense? That's different than this. Okay? All right.
That's what I was confused on yesterday. I didn't really understand the difference.
But now do
basically-
you?
Yeah, now I do.
Okay.
Achondroplasia is basically a grown person with a grown face, but just the limbs.
Arms and legs are small. It's genetic.
Okay.
Yeah. Okay. All right. And you can't stretch out their limbs if you want to with artificial means. All righty. Oh. Let's make sure we know this one. Remember, ADH is all about what? Hold water, right? Okay. So, if you have a lot of solute, a lot of sugar, a lot of blood, a lot of salt in your blood, do you pee more or pee less? Pee less. Your body releases, your brain releases ADH and says, hold the water and water down this solute in my blood. Got it? I don't want my blood to turn solid. I want to keep it liquid. So I pee less and hold more. Of course, when you pee less and hold more, do you get higher blood pressure or lower blood pressure?
Higher.
Higher. And that's why when somebody has high blood pressure, the first thing the doctor says is cut down on your salt. Because water what?
Follows salt.
Yeah. So the water is going to go into your blood, giving you more blood volume and therefore more blood pressure. Okay? Now, the opposite. What if you have watery blood with very little salt or very little? What do I want to do? I don't want to hold more water, so I stop the don't pee hormone and causing me to what? To pee. That's how you get rid of it. 10-4? Because that's what we're doing with our hormones. We're trying to reach homeostasis. I don't want to have too much water in my blood. I don't want to have too little water in my blood. And that is the hormone that tells your kidneys to pee more or pee less. You know, the name is ADH, don't pee. So that's what it does. So if I just turn it off, then you'll pee. Got it? Okay. Oh yeah, notice at the bottom, it says alcohol, right? Alcohol turns off your ADH. So what are you going to do? Pee. But what are you peeing?
Water.
Only water, which shrivels up your brain cells, and we call that a hangover.
So drinking alcohol, does it make you like dumb like marijuana does? Or what does it do?
I don't know what you mean by dumb.
Because you said like the brain cells swell up, right?
No,
When you
the
drink
brain
like-
cells shrivel up.
Shrivel up, so they get smaller.
Right. So you tell me, is that good for you or
No,
bad
that's
for you?
good. That's bad.
Well, why do you think they call it DUI? Driving under the influence. Are you a better driver when you're drunk? Yeah, so you can call it dumb, but what it is slower reactions, less understanding of what you're doing, and you do make dumb mistakes.
Okay.
Does that make sense? In other words, I wouldn't recommend you and then try to study. You know what I mean? Alrighty, let's see. Please. This is a good one. 2 kinds of diabetes. Is that one of your study guide things?
Yep.
Sure is. Diabetes insipidus, diabetes mellitus. And that's why when you go through your clinical rounds and you go to nursing school, don't just say, oh, my patient has diabetes, because it's 2 kinds. Alrighty? Now, they both pee a lot, but that's what diabetes means. Freely peeing. Got it? This is the peeing part. Dia means freely. What is the dia word that means freely pooping?
Diarrhea.
Diarrhea. How about freely sweating? Diaphoresis. Got it? So dia always means I'm doing a lot of it. Right? Okay. You see, they put the words insipid and mellitus, ancient Greeks, because this pee-pee had no taste. And this pee-pee tasted sweet. Got it? Remember I said to you guys last night, if 2 people came to, Dr. Hippocrates and he peed, yeah. Okay, that tastes like nothing. You've got the first disease. Oh, yours tastes sweet, you got the other disease. 10-4? Because here, your ADH was turned off, and all you're doing is peeing out water. Here, nothing to do with ADH. Here, your insulin isn't working. So you're building up a bunch of sugar in your blood, and your body is not going to allow your blood to get turned into a block of sugar. So what are we going to do? Pee it out. But we don't pee out Dixie crystals. We have to pee out water with the salt, with the sugar. See, that's why water follows salt or water follows sugar. And when we get to the blood chapter, water follows albumin. That's a protein in your blood. Okay? We'll explain why that works. Okay? But it's always water following. See? Water is never pumped. Water is drawn. We call that osmosis. Water is pulled from one body cavity to another body cavity, either into your blood or out of your blood, into your cells or out of your cells, depending on how many solutes you have in both compartments. Alrighty? Okay. So, why do I get copious urine? Because you've turned off ADH. Why are you thirsty? Because you lost all your water and you're thirsty. Okay? Why are we peeing a lot here?
Get rid of the
Get rid of the
sugar.
sugar. Why are we thirsty?
And
Because we're losing all the water. So what's the one other thing that a diabetes mellitus patient will display? We call this polyuria. We call this polydipsia. It's like I'm going to dip a ladle in the water bucket and drink more. Polydipsia. Polyuria, polydipsia, excessive drinking. Okay? What does a diabetes mellitus patient do on top of those two?
They're eating sugar.
Polyphagia. You start eating more and more. Why?
Because your body isn't getting the sugar from the blood, so
That's
it feels like it
right.
needs more.
So your body cells are saying, hey, where's my sugar fix?
That's for the insipidus.
No, with this.
For the
Sugar,
mellitus.
sugar,
Oh,
sugar.
okay.
Ain't no sugar in here. No sugar at all. Get sugar out of your mind here. Sugar. Okay? We have sugar in our blood, but none of it is making into our cells. So all of your cells are screaming and telling your brain, eat more. I don't want one donut, give me 12 donuts. Got it? And so here you are adding more and more sugar, peeing more and more sugar out, and your body is still screaming, where's my sugar?
That's how you get.
And that's why you keep eating.
Like 300 sugar in your blood, or
Yeah, 300, 400. I had a student tell me that they had a patient that came in with 400 levels of sugar. I'm like, dang, that's a lot.
It makes me think.
My doctor goes crazy when mine's 125 or 150.
It always reminds me because my manager has diabetes mellitus, and he's constantly wanting to eat more sugar. More sugar.
Now, does he have type 1 or type 2?
I'm not sure.
Okay, have you ever heard of type 1, type 2? Please be aware this is not the answer. This is not type 1 and that's type 2. No. Type 1 and type 2 are both mellitus. Type 1, you're born with it. That's why it's called juvenile onset.
He has type 2.
Got it? Type 2 you get in later life because of bad choices. Got it? Drinking too many Cokes, drinking too much sweet tea down here in South Carolina. Okay? And you eventually wear out your pancreas and says, I can't make any more insulin for you, buddy. Okay? Now, a lot of that can be controlled by medications, like your Jardiance and metformin and stuff like that. Okay? Not type 1. A type 1 patient has to inject themselves with insulin because their pancreas isn't working at all.
So type 2, you just take a pill. You're not having to
you can
inject
take a pill.
insulin?
You don't have to unless it's really far gone. Okay?
It's like
Now,
the last.
Yeah,
second
the last
thing.
thing, yeah.
This is something they started with later on, so
Right.
they can control it.
Start on later on. You can
unless
control
we
it by
were
not
born with
eating
it, yeah.
or drinking the bad stuff and by taking medications that help your pancreas produce the insulin.
So someone that was born with it can't help it with.
Yeah, you can help. Yeah, you're not on medication. You're taking insulin because you don't have any insulin that you're making anymore. Now, what causes juvenile? We're not really sure, but it's some kind of autoimmune disease. Your own white blood cells are attacking the beta cells that make insulin. And they destroy the beta cells that make insulin in your pancreas. Now your pancreas can't make it. That's all there is to it. So if you can't make any insulin, you need to shoot yourself with insulin. Does that make sense? Now, I had a student last night, remember?
Yes.
She said that her son, they think, got it from a virus. Because one of the things viruses do, we'll talk about that in detail when we get to the defense mechanisms chapter. A virus cannot multiply itself like a bacteria can. So a virus has to hijack your cells, hijack your DNA, and force your DNA to make more viruses. Okay? Well, in some cases, the virus has so screwed your DNA that now your cell becomes cancerous. That's what they believe is causing cervical cancer and stuff, an HPV virus. Does that make sense? So that's what they're worried about, is that maybe all these cancers are being caused by viruses in the environment. Maybe it's not genetic. Does that make sense? Okay. All right. Good? Okay, let's look at some more diseases.
Because all the diseases you talked about are all to do with the growth hormone, right?
So far.
So far?
Well, this has to do with ADH
Well, yeah, okay.
and insulin. Okay. Here we go. Thyroid. Here we go. All right. Poor little baby. born without enough thyroid hormone, which causes permanent brain damage because the brain never grew, and we call that cretinism. Alrighty? This person has an overactive thyroid causing Graves' disease, part of which is your eyeballs poking out. What are your eyeballs poking out called? X ophthalmos. Ophthalmologist, catch your eyes. X. Eyeballs sticking out. Okay. Now what is this? This is a goiter. A goiter, also known as mixed edema, edema of your myxos mucus glands. This is your thyroid growing extra big because it's looking for iodine. Remember, I need 3 iodines to make your triiodo and 4 to make my tetraiodo thyronine. If you have no iodine in the ground, the roots of the plants you're eating from don't have any iodine, and when you eat them, there's no iodine in your diet. And so your thyroid says, well, I'm going to get bigger, because if I get bigger, I'll have more blood vessels, and if I have more blood coming to me, maybe I'll get some more iodine. Got it? But there are certain parts of the world where there's no iodine in the ground, mostly areas like islands and whatnot. So it doesn't matter what you eat, everybody is one of these. And they come over here and go, what's wrong with your neck? What's wrong with your neck? Because you have got one of these big things underneath there. 10-4, big watermelon. All right? So, but we can give you iodine. We call that iodized salt, which is a combination of sodium chloride and sodium iodide. Got it? Iodized salt if you are low on iodine. Okay? We can also check your thyroid by giving you an injection of radioactive iodine, because your thyroid sucks it up, and then we can take a picture with a PET scan or a CAT scan and see where it's glowing. Okay, that's the part where it's taking up a lot of iodine. Does that make sense? Okay, it's a non-invasive way to do that. Yes, ma'am.
So if she were to eat more iodine, would that disappear or no?
Yes.
Oh, okay.
Yeah. But in many cases, it gets too big, they have to be operated on. Okay? That's also a dead giveaway that maybe there's something wrong with your thyroid, like a cancer. All of a sudden, a little lump starts growing here. Yeah, it's not because of lack of iodine. That might be because now it's a tumor. All right? There are many cases of a nurse noticing that in somebody and saying, you need to go get this checked. All righty?
Will you talk real quick about how, so with the first one,
Yeah.
is that not getting enough
Iodine, yeah.
or with the baby?
Yeah, the baby did not
Okay.
have enough iodine because something wrong with his thyroid.
Okay.
So he's getting, his brain shriveled up because he can't grow.
The mom didn't eat enough iodine?
Or the baby didn't have a thyroid that's working properly. That's the key. Okay? His thyroid isn't doing the work that it's supposed to be doing, which is metabolizing his brain as it grows.
So all 3 of these are from not getting enough iron.
No, that's not enough, not enough. This is too much.
Okay.
This is
okay.
hyper, unfortunately. See, that's the infantile, that's the goiter, and this is the Graves' disease, which is too much.
Okay.
You're making too much thyroid hormone, which makes you lose weight and your eyeballs bug out. Okay? And I've seen this before. I had a colleague at another university. Look, I've lost so much weight. I said, oh, good for you. Are you doing a diet? No. I don't know why I'm losing weight, but I got a diet. And I'm looking at her like, but when you look at yourself every day in the mirror, you can't see this. And I said, I'm not a doctor, so I can't diagnose anybody, but I did say, you might want to have a yearly checkup. Okay? Saw her 6-7 months later, and she goes, you'll never guess. I said, what? I was diagnosed with Graves' disease. I went, no. I knew it because I saw it. Unexplained weight loss and eyeballs sticking out. Okay? That's Graves' disease. Too much. Okay? Thyroid. All right. the test is when? Yeah. All right. All right. Remember we talked about calcitonin and PTH being antagonists? Yep. So, what's the disease if I have too much PTH?
PTH.
What's PTH do?
They
Takes it out.
Takes what out?
The-
Don't say it.
calcium
my
in your
classroom.
bones.
Calcium out of what?
Your
The
bones.
bones.
Okay, so what's that disease called?
Osteoblast.
No,
No.
that's not a
I mean,
disease.
Osteoporosis.
No, it's not a
No.
disease. That's a cell.
Osteoporosis?
Thank you. Osteoporosis. Your osteos become porous. Remember we talked about that in 210. That's too much PTH.
I'm sorry, you said the Graves' disease is too much iron.
Thyroxine.
Too much thyroxine.
Yeah, too much.
With the Graves' disease and the other ones, is it specific to T3 or is it also T4?
Oh, I don't know about that. Yeah.
Okay.
And if it is, I'm not sure.
We don't need to know that for
Nope,
the test.
nope,
Okay.
Okay. You do need to know Cushing's disease. That'll be on your test. It'll also be part of your nursing. Alrighty? What's Cushing's disease? Excess glucocorticoids, cortisol. Got it?
Okay.
If your body makes too much cortisol, you get this. The moon face and the buffalo hump. What is that? It's actually deposits of salt in those areas, which draws what towards it?
Water.
Water. That's why you get localized edema here and here. Okay? Not everywhere else, just here and here. Okay? Now, that's if you make too much cortisol. However, can you be given a lot of cortisol? Yes. And that's why John Kennedy, his face was puffy in his presidential years because he had a very bad case of Addison's disease, which is a lowered amount of cortisol. So they shot him in the butt 12 times a day with hydrocortisone, man-made cortisol. And he got the buffalo hump and the moon face. Got it? And then he was assassinated, so we never saw it progress. Does that make sense? But that's it. So if you have the disease, it's called Cushing's disease because you make too much. If you're getting the shots and you're getting a lot of it, we call that Cushingsonism. Got it? Because it looks like, it mimics Cushing's disease, but it's not the disease. You get the same results. Okay? So that's Cushing's. Too much cortisol. Different ways to take in your cortisol. Got it? All sorts of inhaled corticosteroids. And this is a lack of cortisol. A lack of cortisol is called Addison's disease. You get a darkening of the skin even though you haven't been outside. See, Kennedy always had that tanned look when he was a senator. Not because he was always outside, but he had Addison's disease. Okay? Now, one of the problems with Addison's disease that makes it dangerous, high levels of potassium. Okay? Now, I don't think I have that here. What the heck? I'll make it work. You know, however, I've always got to make a manipulative sodium and potassium. Okay? Sodium and potassium. How are they arranged in your blood?
Sodium is in the blood.
Sodium high, potassium is low. Why?
potassium could kill you. If
The
it's too
sodium
much.
potassium pump does this. It pumps the sodium out into your blood, pumps the potassium into your cells. See, in your cells it looks like this. High this, low that. In your blood it's high this, low that. 10-4. What happens when this starts creeping up?
Makes your heart stop.
Makes your heart stop. So do I want this? That's Addison's disease. Got it? That's one of the big problems with Addison's disease. All right? You'll never find sodium and potassium the same in your blood. It's either this way or it's this way. This is correct. This is incorrect. 10-4? Okay. And what makes it stay like this? Sodium potassium pumps are working correctly. Okay? All right. Had a student, her mom was misdiagnosed with diabetes, mellitus, for years. Why? Because this messes up your sugar, lowers your blood sugar levels. Okay? So they thought, oh, you must have diabetes of some kind. Here, do this medicine. Didn't work. Next doctor. Oh, it must be diabetes. That didn't work. Third, fourth, fifth doctor. Finally, she went to another doctor who said, you know what? Let's start from one assumption. It isn't diabetes. Because none of the diabetic medications are working, and you still have this situation. He did a complete blood workup and noticed that her potassium levels were through the roof. He knew exactly what her problem was. Addison's. So guess what she got? Hydrocortisone shots. Got it? To reverse that. Alrighty? If they hadn't done that, she would have been dead. Now, isn't tanning your skin one of the symptoms? Yes. She's an African American lady. They couldn't tell that her skin was getting darker because it's a slow, gradual thing. Does that make sense? Even family members couldn't tell it was getting darker. So, of course, how would a doctor seeing you for the first time know if your skin was too dark? 10-4? That's why blood work is the key. 10-4? All right, so Addison's, Cushing's. Too much, too little. Cortisol. Oh, what did we use cortisol for? Why does your body have cortisol in it? What's cortisol do? Why do we give somebody cortisol? Well, I know this one because one of our colleagues here had a very bad case of rheumatoid arthritis, autoimmune disease. Got it? Well, if your white blood cells are attacking you, what's the best way to help? Stop the white blood cells. Well, guess what? Cortisol is anti-inflammatory. That's why we give it to people, to reduce inflammation, to stop the white blood cells that are causing the inflammation. Trouble is, it suppresses your white blood cell count. And this poor lady caught COVID and was dead in 3 days. She was diagnosed on Friday and died on Sunday, which is a shock to all of us. But this happened, back in 21, something when COVID was first hitting. That's what we call a compromised person. Got it? So, that's what I'm saying. You can get Cushing's syndrome, and she did. She had the moon face and the buffalo hump because she had been on hydrocortisone shots or pills or whatever it is for many, many years to help her with her autoimmune disease of rheumatoid arthritis, where your white blood cells attack your joints. Okay? So, cool beans? But that's the only reason we give somebody these kinds. And is cortisol a steroid? Yes. Cortisol ends in OL, so it's a lipid, right? And it's a steroid. And that's why you might have heard of this. Hey man, give me an NSAID. Ever heard of an NSAID? What's an NSAID? Am I still on that?
Yes.
Okay. Non-steroidal anti-inflammatory drug. So, in other words, I've got inflammation, but I don't want to take a steroid. I don't want to take cortisol or man-made hydrocortisone or prednisone. Any zone is one of those things. Okay. So that's Tylenol. Tylenol reduces inflammation without being a steroid. Therefore, that's what an NSAID is. Okay.
Albuterol, you said on the video, is a type of.
It's a combination of a cortisone and an epinephrine to open up your lungs immediately. That's called a rescue inhaler. Got it? And notice on the commercials even, they say, don't overuse this. Because what's going to happen if you keep hitting your heart with epinephrine? Yeah, exactly. So you take your regular, and the regular ones are pure steroids. They're pure cortisol. To open, get rid of the inflammation that's making your airways close up. So we're going to open them up. But it's not the same thing as the one that got epinephrine with it, which is the rescue inhaler.
So I'll say I use an inhaler and I call it a breathing machine. What is the actual name for it?
Nebulizer?
Nebulizer.
Okay.
And I use albuterol on both. The rescue inhaler is the one that would have the epinephrine. The one that you use on the nebulizer is just albuterol.
Right. Yeah, okay. That's just the cortisol type. Yeah. Okay? And that's why it's a daily regimen, not a rescue inhaler. Got it? And they'll even say that, don't combine this drug with your rescue inhaler on a daily basis. Got it? They're telling you. The rescue is like, I can't breathe. So quick, get it to open up. Got it? Otherwise, we just want to slowly open it up with a cortisol derivative. Okay? Excellent. Very good. Don't forget that you have little white islands in your pancreas called islets of Langerhans. The rest of the cells are called acinar cells, and they make digestive enzymes, which we'll learn about in the digestive chapter. But here, the blue cells that are colored blue are the beta cells, which make insulin, and the red ones are the alpha cells, which make the opposite of insulin. What's that?
Glucagon.
Glucagon. Okay. Don't say glycogen because that's the stored version of glucose in your liver. Okay. Cool beans? Yeah, some all this stuff. Okay. And again, just like your PTH and your calcitonin, right? It's a seesaw. Got to get back in order, right? Oh, I need more glucose. Release glycogen. I got too little glucose. Release the glucagon. I got too much glucose. Release the insulin. Get me back down. Got it? Okay. Antagonists. See, there's your polys right there that we talked about earlier. Let's see, there's your type 1 and type 2, juvenile, mature onset. And then there's other glands that do other things. All right. The ovaries make estrogen, progesterone. The testes produce testosterone to help the sperm grow. The placenta produces estrogen and progesterone as well. Okay? Your stomach makes gastrin, another hormone. Okay? Your heart makes atrial natriuretic peptide. Your kidneys produce erythropoietin, which we're going to spend a lot of time on next week, because that's the blood chapter. Erythropoietin made by your kidney goes to your bone marrow and says, build me some red blood cells. That's why it's erythro for erythrocytes. Poietin is just another version like Genesis to build. Build red blood cells. So what is leukopoietin? Build white blood cells, because leuco means white. Does that make sense? Leukocytes, white blood cells? Okay. Now there is no hormone for there is no hormone called leukopoietin. But the process is called leukopoiesis, the building of white blood cells. Just like if I use this, the process is called erythropoiesis. Cis, S-I-S, is the process of. Itis is inflammation of. And osis is condition of. Does that make sense? Okay. See, something also makes ghrelin, which makes your brain say, I'm hungry. The word ghrelin comes from growl. Got it? When somebody's growling because it's hungry. Your skin makes cholecalciferol, which is a precursor for the ability to handle calcium. It's a precursor to your what? It's vitamin D. It's a precursor to vitamin D, which allows you to absorb calcium out of your milk and out of your cheese and put it into your blood. Without vitamin D, the calcium goes right out. Came in, came out. Okay? Got it? So that's what I'm saying. This is just other glands, so it's just little things to keep in mind. Where am I going to see this again? In the reproductive chapter. Does that make sense? I'm going to see this in the digestive chapter. Got it? You saw this in the skin chapter back in 210. Right? And of course, we're going to see this in the blood chapter, because the kidney's making your bone marrow make more blood.
Are all the chapters this semester going to be based on like this stuff like SAL, ADH, and just
Not, I wouldn't say based on, but I'm just saying a lot of chapters are going to do the same things.
okay.
My students notice it's very difficult to learn all this endocrine stuff now because there's so much of it. But you're going to see it again in the blood chapter, and again in the heart chapter, and then there's some more in the lungs, and some more in the digestive, and some more in the reproductive. And by the time you get to your final exam, that's old hat. You got these now. You've seen them 3, 4, 5 times. Does that make sense? So it may seem overwhelming now. Alrighty? Is that the end of it?
Like on the
Yeah, study guide?
I was gonna say one more that I wanted to make sure I got. It says know the main functions of each type of blood cell. What specifically?
Blood cell?
Is that not supposed to be in there?
No, because your blood cells are next week.
It might be.
Oops. That must be an oops.
I was
on my
confused.
Part.
I was
blood
trying
cells.
to think
Yeah. We're doing the white blood cells next time.
Okay.
Sorry.
Yeah, because you didn't go through all the slides. Oh, you were almost done yesterday, but you didn't go through all.
No, I didn't go through all of it. You want to be here till 9:30? I didn't.
No.
Yeah.
No, I mean like through the 102 slides.
Yeah, but I mean, remember, there's a
Hey,
lot
we
of
don't have to.
pictures,
We don't.
a lot of explanations, and that's why watching my videos is me speaking slowly.
Yeah.
Okay? And you can always hit pause. Got it?
Actually, you know what? If
No.
you want, touch on the last one. Discern the difference between humoral, neural, and hormonal stimuli.
Perfect. That we can do.
I
We
think
did that
that's-
one last night, didn't we?
I think that's the last thing.
Yeah.
Fine.
I'm
Yeah,
pretty
we
sure.
can do that.
Is your class full? The classroom, is it full with a lot of people? Because I couldn't.
I'm online.
Oh, you're all online?
Yeah.
Yeah.
You didn't get
Yeah,
to.
see, that's
sign
why I'm
up.
offering them to be in here. It helps.
So wait, is there an in-person class?
There was one that was full. I assumed that was the one. I had to sign.
So-
sign up for the one that was only one night per. But that's better than.
Mr. Weber, so
Yes.
you're doing an in-person 211 class too?
No, I don't have an in-person 211. I got 2 in-person 112s.
Okay.
The only person doing it in person is Mr. Triana.
Gotcha. Okay.
Most of the classes are full for him, so I couldn't. Wait, who's that? That other class in the other room, is that 210?
Yeah.
Yeah, that room is 210.
Oh, yes.
Yeah, Mr. Triano was just doing this 210.
Um,
Okay, here we go. This is your book's quick version, okay, of what we're talking about. To stimulate is to make a organ release a hormone, okay? I can release a hormone by using a hormone. I can release a hormone by using a nerve. I can release a hormone by using a chemical in your humor, in your blood, that's not a hormone. Got it? So, let's start with this one. Calcium levels. If my calcium levels are higher than normal, it makes me produce calcitonin to put the calcium into my blood and bring me back down. If my blood calcium is too low, I produce PTH to dig the calcium out of my bones and build up my blood calcium. Got it? So it's calcium levels that trigger those two hormones. How about water levels? They trigger ADH. How about sugar levels? They trigger
Insulin.
AMP? No.
Glucagon.
Glucagon.
glucagon and
Insulin.
insulin. Got it? Too high or too low? 10-4? Okay. So those are chemicals in the blood that stimulate the release of a hormone. Okay. This is the easiest one. Your sympathetic nerve, your fight or flight nerve, tells the adrenal medulla to release epinephrine, which is your fight or flight hormone. Done. But it's a nerve telling you to release a hormone. Everybody else is this. You know, you got your thyroid stimulating hormone from your pituitary, goes to your thyroid to tell your thyroid to make thyroxine. Make sense? You have your ACTH from your pituitary going to your adrenal cortex to tell it to make cortisol, for example. Got it? You have, all the hormones out of your hypothalamus go down and tell your pituitary to release hormones. Got it? So those are all stimulatory. Hormone telling another organ to make a hormone. That's all this is. Hormone to make another hormone. Nerve to make a hormone. Chemicals to stimulate the making of a hormone. Okay? And that's as deep as it needs to get. Just don't mix these two up. Humoral and hormonal. They both start with an O and an H, you know. Don't. This is in your blood. Well, all hormones are in the blood too. Yeah, but that's why they're saying it's a chemical in your blood, not a hormone in your blood. Okay? Cool beans? All right. What else can I do for you?
That'd be good.
Okay. Yeah, I think we hit the highlights, didn't we? Yeah. And that might be what some folks need to see. If you want to put that up, that's fine. All right. Thank you very much.